Alright, now let's review these practice problems. Before we do that, you notice that we're starting to diverge a little bit from your schedule I handed out to you next week, or last week, excuse me. So, the substitute instructor should have a new schedule to hand out to you that shows the revised schedule for this week and then into next week, since we're diverging a little bit. Okay, so first problem, 33.1. Again, it was a two-part problem. So you're given wavelength and asked to solve for frequency. So in the first part, again, speed of light is frequency times wavelength. So frequency is equal to speed of light over wavelength. In this case, you were given 1 micrometer. Let's see, 3 times 10 to the 8th meters per second divided by 1 micrometer. However, the micrometric prefix is not helpful in the calculation, so what you would want to do is write down the meaning of micro, which if you look in the metric prefix table is 10 to the minus 6, and that is meters per cycle. And meters units cancel out, and you're left with cycles per second, or hertz. So that should turn out to be 3 times 10 to the 14. And you could show the units as cycles per second or hertz. Now, how would you know if that's a reasonable answer? This one is something you can just do by hand or in your head pretty easily. 3 divided by 1 is 3, and using your exponent rules, if you take the 10 to the minus 6, flip it up into the numerator, it becomes 10 to the 8 plus 6, or 14. So that one, you should be able to look at that and decide whether that's a reasonable answer or not. In all cases, when you do calculations, you should be able to step back and look at it and try to decide whether the answer makes sense. Now, what is the book answer for that one? All right, in the textbook, the author shows 30 times 10 to the 13th. Why did he express it as 30 times 10 to the 13th instead of 3 times 10 to the 14th? I don't know. I'd accept either one. I'm not sure why it was done that way, but they're mathematically equivalent, so that's fine. Right, then the second part was using a wavelength of 16 micrometers. So this becomes same problem, just a different wavelength. And then if you do that calculation, that comes out to 1.88 times 10 to the 13th. Cycles per second. Once again, I'm not able to help you with your calculator problems because I'm not there with you. Hopefully you're able to start working through that. All right, the next one was problem 33.3, top of page 659. A microwave radiator used in measuring automobile speeds emits a frequency of 1.2 times 10 to the 9th hertz, what is the wavelength. So you're given a frequency of 1.2 times 10 to the 9th hertz. Determine the frequency or the wavelength. So again, the same equation is in play. Manipulate the equation to solve for wavelength. Since now the answer, you'll see that the answer is in a metric answer. I suppose it could have been done in English as well. So, but we'll stay with metric. Three times 10 to the 8th meters per second. The frequency was 1.2 times 10 to the 9th. And I'm not going to write hertz, I'll write down cycles per second. That's the most helpful form. You'll see that the seconds units cancel out and you're left with meters per cycle, which is the formal units for wavelength. Now the textbook, again, as I've mentioned before, the textbook omitted the word cycle. So instead of the answer being 250 millimeters per cycle, they just wrote down millimeters because it's assumed that wavelength is the length of a cycle. And that turns out to be, it actually turns out to be 0.25 meters per cycle. So if you had expressed your answer that way, I'd be okay with it. You'll notice that in the problem statement, the author didn't ask for specific units, but they decided to express the answer as 250 millimeters. It was a choice. You could express it in millimeters if you wanted to. There are 1,000 millimeters in every 1 meter, and that will give you 250 millimeters. Now sometimes in homework or tests, I will ask for specific units in your answer. But if I don't ask for a certain type of unit in the answer, then that's up to you to decide. All right, now we'll move on to the next one, 33.7. Now I gave you a correction for number 7. I should have given you another one. In number 7, you're asked for the wavelength to be expressed both in nanometers and angstroms. Angstroms is a pretty obscure unit, so we can just skip that. I should have told you that ahead of time. So let's just calculate the wavelength in nanometers. All right, 33.7. So you're given frequency of yellow-green light is 5.41 times 10 to the 14th hertz. What's the wavelength of this light in nanometers? Again, the same equation is in play. Speed of light is frequency times wavelength. We're solving for wavelength. And the frequency is 5.41 times 10 to the 14th. And I'm going to write it as cycles per second. Seconds cancel out, and again you're left with meters per cycle. So this ends up being like if you did this by hand, if you just decided to manually manipulate the exponents, this would end up as 0.5555. 0.555 is the 3 divided by 5.41. And if you take the 10 to the 14th, flip it in the numerator, it's 10 to the 8 minus 14, which is 10 to the minus 6 meters per cycle. But you were asked for nanometers. So how do we get from there to nanometers? And you have to know the meaning of nano, which is 10 to the minus 9. So you can put a conversion in. There's 1 nanometer for every 10 to the minus 9 meters, because 10 to the minus 9 is the meaning of nano. So you can see the meters cancel out, and you're left with nanometers per cycle, which is correct. So now the last thing you need to do is take the 10 to the minus 9, flip it up into the numerator, and then you're left with 10 to the minus 6 plus 9, which is 10 to the third, which means now you're just moving the decimal place over 3. So that's why the answer ends up being 555 nanometers. And remember, the units are still nanometers. I'm sure there are lots of other ways to do that. Here's another, let me show you another way to do that. Another way to do the conversion is you could recognize that 10 to the minus 9 is the meaning of nano. So what you could do is you could force this power of 10 to be 10 to the minus 9. And the way you would do that is if you move the decimal place over 3, that would cause the exponent to be minus 9, which is nano. So some of you may think through it that way, and that's okay. Okay, that's number 7. The last one is 33.9, which is application of the speed equation. The sun is approximately 93 million miles away from us. How much time is required for light emitted by the sun to reach us on Earth? So you're given distance is 93 million miles. You're going to solve for time. Now, since the distance was given in English in miles, then we can now use the English value for the speed of light. So in this case, since we're talking about light, the travel of light, we know that the speed of light is 186,000 miles per second. So we're dealing with distance, speed, and we're asked for time. So we're using the speed equation. Speed is equal to distance divided by time. You need to manipulate the equation to get it into the right form. Time is equal to distance divided by speed And so it would be your 93 million miles divided by 186,000 miles per second. The miles units cancel out, and once before, when you divide a fraction by a fraction, it's the same as multiplying the numerator by the inverse of the denominator. So the second units do flip up into the numerator. So this actually ends up being 500 seconds. So since the problem statement didn't ask for specific units, 500 seconds would be acceptable. You'll notice that in the text, the seconds were then converted into minutes. So about a little over 8.5 minutes. So that tells us that one day when the sun actually runs out of fuel and burns out, it'll take us 8.5 minutes to know it. I don't think we'll be around. So let me give you two more practice problems that you can work on, and then we can talk about them later. So this will be problems 33.11 and 33.13. End of chapter problems. Two more problems that just practice the use of the speed equation. Again, these are just for practice. And I do believe that the answers that are in the text are correct. Okay. And then also for tomorrow, what we're going to start looking at tomorrow is section 33.5, shadows, and that is going to be the last section that we talk about in this particular chapter. So that starts at the bottom of 649 on to the top of page 651. And then after we're done with that section, then we're going to move on to reflection and mirrors, chapter 34. All right, so I think that's all I had for you today. We'll see you tomorrow for a discussion of shadows.